Proof that e to the I pi plus 1 is equal to 0. First, let's look at the complex plane. Let's consider a point on this plane and call it z. In rectangular form, we can say that z is equal to x plus iy. And using polar form, we can say that z is equal to r multiplied by cosine theta plus I sine theta. The expression cosine theta plus I sine theta can be expanded in terms of Taylor series, and it looks like the infinite sum in blue. We can write the same infinite sum in terms of I theta, and it looks like the infinite sum in green. If we say that x is equal to I theta, we can say that the function of x is equal to the infinite sum in orange. We will notice that f of x is equal to f prime of x, and this implies that f of x is equal to e to the x. But since x equals I theta, f of x is equal to e to the I theta, and therefore f of x is equal to e to the I theta, which equals cosine theta plus I sine theta. If we look back at our original problem, where z was equal to r multiplied by cosine theta plus I sine theta, we can now see that z is equal to r multiplied by e to the I theta. If we assume that the radius r is equal to 1, we get that z is equal to e to the I theta, which equals cosine theta plus I sine theta. If we substitute pi for theta, we get that z is equal to e to the I pi, which equals cosine pi plus I sine pi, which equals negative 1 plus 0. So e to the I pi equals negative 1. And if we add 1 to both sides of the equation, we get that e to the I pi plus 1 is equal to 0, and we are done.